Okay, so for this drawing video, what I'm going to do is I'm going to draw an elevation and plan of a cylinder. I'm going to then cut the cylinder on elevation, and I'm going to show the true shape of the cut surface. After I show the true shape of the cut surface, I am then going to develop the cut side of the cylinder. So I'm going to unfold the side of the cylinder and show how the cut impacts on the side. So first of all, the position of the cylinder on the elevation. So down from the top of the sheet, 145 millimeters to the XY line, and in from the left hand side, 50 millimeters to the bottom left point of the elevation of the cylinder, and another 30 millimeters into the center line of the cylinder. So the overall base size will be 60 millimeters. Now the height of the cylinder on elevation is going to be 90 millimeters. So 90 millimeters is going to be the overall height of the pre-cut cylinder. For the plan, you're going to move down 50 millimeters to the center point of plan here with regards to the drawing of the circumference of the plan of the cylinder, so the circle. Okay, now I'm going to proceed to draw that in hard. Okay, so to continue on then, we have the elevation of the cylinder and we have the plan of the cylinder inked in. Okay, so hard lines, black ink. Now what I'm going to do is I'm going to impose a cut on the elevation. So the cut itself is on the left hand side, it is 70 millimeters up on the left hand side of the cylinder, and it is cut at 30 degrees. So up 70 from the left hand side, and it is cut down from the left hand side at 30 degrees. Now I'm just going to put the cut in place as a red line. So that is showing you the cut on the elevation at 30 degrees. Now what I am going to do is, first of all, I'm going to unfold the full cylinder as a development. Unfold the full cylinder as a development. The next thing I'm going to do is I'm going to impose, well, what does this do? What does this cut do to the sides? Now, I could also start with the cut surface itself, but I'll leave that to last. I'm going to start with the development itself. Okay, so first of all, what we have to do is, in order to develop the sides of this cylinder, because it is a circle and plan, okay, and on elevation it is a rectangle. So what I want to do is I want to unfold it so that the full length of the circumference of this plan is unfolded here on the XY line. So how do I measure the circumference here? Well, we measure very simply by dividing through the center line here this circle into an equal number of segments. Okay, now we do that by using a 30-60 degree set square, okay, in order to divide it into 12 equal segments. So using your t-square, put the set square at 30 degrees through the center point of the plan, and then you simply bring your line through the center point. Okay, you turn the set square around, do likewise then with regards to the other side. Okay, then we do the 60 degree line. Both sides again. Okay, and then you do the vertical and horizontal. Now we have the plan divided into 12 equal segments. Now I only need one for developing the length here. I only need one of these, so I'll put this in as a green line. Okay, so one of these, where they hit the circumference here, okay, where they hit the circumference, what I do is I simply bring those 2 points across here. Okay, and that green line now is 1/12 of the circumference. So I use that as a measurement on my compass. So I'm going to my plan here. Now obviously the base of the elevation is 60 millimeters, so the radius of the plan is 30 millimeters. So the diameter of the plan is 60 millimeters, and that is the length of 1/12 of the circumference. So I step that off 12 times. Measure off. Okay, and I'm just going to mark each point here. So I've got my first point, 1, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11, 12, and then back to 1. Okay, now what I'm going to do is I'm going to index these points. So I'm going to start here. I'll start here at 1, 2. No, I could start it down here. 1, 2, it doesn't matter. But I'm just index. I have to link all of them in the same way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1. Now on this one here, I'm unfolding it. This point here, if I bring it down here, is 0.4. Okay, 0.4. Okay, so this here is going to be 0.4. And how it's unfolding, so if I'm unfolding it like so, then this is the next point is going to be 0.5, 0.6, 7, 8, 9, 10, 11, 12, 1, 2, 3, and 4. So the first and the last point will be the same. It comes in on itself. Okay, so that stretches out the circumference here as one line here on the elevation, on the XY line. So what I'm going to do is I'm going to bring all of those points up. Now as a development, I'm going to first of all draw it in green. Okay, there's a green line here. So that's the top point. The bottom point here. And the last point. So what we have here unfolded, we have the full development of the side of the pre-cut cylinder, okay? And we stretched out this circumference, we divided it into 12 equal parts, we used 2 and 3 there as a straight line between them, and stretched out the compass using that as a radius 12 times on the XY line. And we listed the points, indexed the points on plan, points 1, 2, 3, 4, all the way around on the plan, and then we correlated the points from the plan. So this is the beginning point, so you're unfolding it at this point here, okay, and we're unfolding it all the way across from point 4 to point 4. So the next thing I do is, okay, to show how that impacts on the cut, what I'm going to do is I'm going to bring up the points. I'm going to use the red line here, and I'm going to bring the points up from plan. Okay, so point 10 is already here, okay? Points 9 and points 11, I'm going to bring those points up. Alright, bring them all the way through. Points 8 and points 12. Bring all the way through. Then point 7, point 1. All the way through. Point 6 and 2. And points 5 and 3. So what we've done is we've brought up all of the indexing, all of those 12 divisions, okay? We brought them up to the elevation, okay? To the elevation. Now, when I look down on the elevation and I see the plan, that cut line is not going to change how this looks here on plan, because it is still a circle, because you're looking down onto this cut here, not as an inclined cut, but as a horizontal. So you're seeing this width on the horizontal when you look down. What I'm doing here with regards to the sides first, I'm going to show, well, what this looks like with regards to the imposition of the cut here on the sides. Now again, I have to correlate all of these points which I brought up to the elevation as these lines here, okay? I'm going to correlate them onto the development here. So each of these lines here correlate with these points here. Okay, so I'm simply going to bring these points up in the same way I brought those points up from plan. So I have points 1 around through 12, okay, on the plan. Okay, and I'm going to correlate then these now on the elevation. So you can see here on the outside we have point 10. This point here, that is point 10. This next line here, where it intersects with the cut here on elevation, is going to be points 9 and 11. So this point here is going to be points 9 and 11. That's this point here. Point 10 is there. The next line in is going to be points 8 and 12. So this point here, 8 and 12. The next point is going to be point 7 and 1. Okay, 7, 1. Next point is going to be 6 and 2. 6 and 2. Okay, next point in is going to be points 5 and 3. Okay, 5 and 3. And the last point here is going to be point 4. Okay, now what we're going to do is simply correlate these points, the points of intersection between the lines, the divisions here on plan, brought up to the elevation, and now we've indexed them on the elevation, and we've also have these points here indexed on the development. So we're simply going to bring these points across first of all. Now, you can see now I've brought all of these points across now to the development. And what I'm simply going to do is I'm going to mark the points of intersection. So I'm going to relate the indexing to the various points. So point 4 stays already on the cut. So point 4 is here. So I bring that across, all the way across. Point 4 is also here. So I'm going to mark point 4 here. Okay, that's the first point there. Points 5 and 3. So this is point 5 here. And point 3. Next one is 6 and 2. So I'll bring that across. This is 6 here. And this is point 2. Next point is point 7, 1. I bring point 7, 1 across. I've got 7 here. And I've got 1 here. Okay. The next one is points 8 and 12. So 8 is here. And 12 is here. The next point is points 9 and 11. Point 9 here. And point 11 here. And the last point is point 10, which is at the very top. Now, I have all of these points here. When I connect those points up, when I connect all those points up together, that will give me the cut on the development. It'll show how this cut impacts on the development of the side. Okay, so all I'm simply going to do is connect those points up. So I can very carefully just bring those points together, like so. Now, what I'm going to do next is I'm going to use a French curve to draw this in as a hard line. And I'm going to use a different color to differentiate it from the rest of it. And then I'm going to move forward. So I'm just going to do that next. So we have the cut imposed on the development here. Okay, now I'm just going to fill this in a little bit harder here on the bottom with the green ink. And the side here. Now I'm going to shade that in using a brown coloring pencil. This is the development of the side here. Okay. Now what we're going to do is we're going to look at the cut itself. That's the next part. How does this cut impose itself with regards to the elevation? And what is the true shape? When you look down on plan, you're not seeing the true shape of this cut surface here. Okay, the actual top part. So what does the top part actually look like? So we can do that in a number of ways. I could develop it off the basically the cut here, drawing a parallel line and basically developing it over here. But I'm not going to do that over here. I can simply just bring a parallel line across here and draw it over this side here, rather than drawing it across here. Okay, so it depends on, like I could develop a number of different ways, but I'll show you how to do it in this instance here. Okay, so just on the side here. So the point 4 there, okay, I will be bringing across. And point 10 is also brought across. So I'm simply going to draw a parallel line. So that's now a parallel line to this cut here. Now I'm going to again draw it in as a red line. Okay, so from this point to this point is a parallel line to this cut. Now what I'm going to bring across as well are the different points of the cut. So points 10, 9, 11, 8, 12, 7, 1, 6, 2, 5, 3. I'm bringing all those points across. Now I'm just extending these lines here that I've already established here on the development, bringing them across. Now, where each of those points intersect with this red line here, I've got this point here, point here, point here. Now, if I correlate them here, 9, 11, well, first point is point 10, so that's going to be point 10 here. This point here is going to be 9 and 11, okay? This point here, the next one down, is going to be 8, 12. This point here is going to be 7, 1. This point here is going to be 6, 2. This point here is going to be 5, 3. And the last point is point 4. Now I'm not going to mark them on the cut line. What I'm simply going to do is bring those points across. Okay, I want it at 90 degrees to this point here. So 90 degrees to this line, I should say, to the cut line. So I'm simply going to bring those points across now. So I've already got the first and last point. The first and the last point, point 10 and point 4, they can stay on that line, so I don't have to bring those points through. But the rest of them I do. So now, points 10 to point 4 on plan is here, point 10 to 4. Okay, so first point, point 10, I'll put it in green here, point 10, and this is point 4. But for me to establish, well, what are the other points? What I'm simply doing here, in order to draw the true shape again, I'm using point 10, 4 here as a swivel. This is it here on the cut. And what I'm simply doing, I'm establishing two pieces of information, bringing them together. So I'm establishing the true length of the line from 10 to 4. So this line here, 10 to 4, as a true length line is here on elevation. Okay, so I've got that now here, brought it parallel. So that's the true length here, 10, 4 is the true length of this line here, 10, 4 on plan. Okay, but I've got my true widths on plan. Okay, so I'm amalgamating, right, the true length with the true width, and with that information I will establish the true shape of the cut surface. So the first point up is points, okay, if I start from point 4 here, so look at point 3 and point 4 on the plan there. Okay, points 3 and 0.5. Okay, points 3 and 0.5, the width of those, each side, from that line 0.4, which is the center line going through there. Okay, so I go to this correlating point here, right? So I swing each side of that line. Okay, I then go to the next line, which is 0.2 and 6. Okay, points 2 and 6. And I swing both sides on there. The next point is the center line here, then the vertical. So 0.1 and 0.7, 0.1, 0.7. Go to the correlating point here, 0.1, 0.7. Next point is points 12 and 8. And the last points to swing around is points 11 and 0.9. So just mark those points. Now what you'll notice is that this is not a circle, it is an ellipse. Okay, it becomes an ellipse. So when a cut is imposed on the elevation of a cylinder, when you look at the true shape of this cut surface, it is not a circle, it becomes an ellipse, because you're stretching one of the axes. Instead of it being equal with regards to a radius, you have a major axis and a minor axis, which is on plan here. Okay, so I'm going to index these points now. So I've got 0.4 here. Okay, so you've got say 5 and 3. You have 6 and 2. You have 7 and 1. You have 8 and 12. And you have 9 and 11. Now, all I simply have to do is connect those points up. So once I connect them very carefully, just as you did the true shape here on the sides here, you're simply connecting your points again. Now, I have my outline in here with regards to the cut surface. So what I'm going to use a French curve now to just draw in the hard line on that cut. Okay, so what we have here now established is the cut surface, and the cut itself on the elevation. So looking down on the plan, okay, this is the cut surface here, okay, and then this is the cut surface, the true shape of the cut surface here. Now I'm going to just shade this in a darker color here, and before I shade it in there in a dark color, I'm just going to show some of those points coming across a little bit more clearly. I'll use red just to indicate these lines here. I've established them. So again, just to show what we're developing here, so just looking down on plan, this is the cut here, imposed. Okay, and just on plan here, that's the cut surface on plan. This is a development of cut side of cylinder. Okay, and this is the true shape of cut surface. Okay, and that's the cut imposed here. Okay, cut imposed at 30 degrees. Okay, I hope you found that video useful. Thank you very much.